Okay, so Joanna, it's recording, right, on your end?
Yes, I started recording.
Jay, I think we did it.
It's in the top left corner, Jay. It says recording.
Yeah.
Okay, thank you kindly. Excuse me.
No problem.
No,
Yeah,
no
so I
worries.
think we're all set. Good. So here we go. So let me just start to welcome you one more time to the session here. And let me also remind you, we have two sessions, one here right now and another one in about 12 hours from now. And they work together, but they're also somewhat independent from each other. And digital twins of the ocean, in my view, this is a slide that some of you have seen, is a nice way to combine what we know about the ocean from observations and taking that information that we have from space, from in situ system, from various actors into the data space. And in the data space, we're increasingly making sure that the data are interoperable, apply the FAIR principles, so findable, reusable, and so on. But also this data space is not only fed by what we know about the ocean from observation, but also with an increasing range of simulation capabilities. You could call them ocean models of the various types. And together between data and model, we can build what you might call a virtual representation of the ocean. And that allows us to deliver some knowledge about the ocean to a wide range of stakeholders and partners. Some of the logos that I put down there is a European perspective on this, but it's very clear that this is not a European effort on its own. There's many global actors in this space. So we have observing systems from space in situ, we have data systems, we have cloud-based sharing. So I think we have a broad digital ecosystem that we can use for this exciting opportunity about digital twins. The digital twins agenda is also part of what we call the UN Decade of Ocean Science for Sustainable Development. It's a UN program that has started in 2021, so last year or almost 2 years ago, and it'll run for 10 years, so it'll finish in 2030. And the headline of the decade is the science we need for the ocean we want. And the objective is to transform sort of the ocean science business as usual activity and make what we do in the sciences more readily usable, accessible, and supporting of sustainable development activities. So it's really about new partnerships and benefits sharing. And the decade has 7 societal outcomes, which I won't review here. It's a safe ocean, a predictable ocean, an inspiring ocean, and alike. But it also has a number of 10 distinct challenges, which you can see in small font to the right there. But one of them, challenge number 8, calls for, and I read, through multi-stakeholder collaboration to develop a comprehensive digital representation of the ocean, including a dynamic ocean map, which provides free and open access for exploring, discovering, and visualizing past, current, and future ocean conditions in a manner relevant to diverse stakeholders. So it calls out for that type of activity. And under this challenge, a number of us, it's about 30 or 40 folks, have developed a program which is called DITTO. And what DITTO stands for is Digital Twins of the Ocean. And what it tries to support is this accessible ocean with open and equitable access to data, information, and technology, and this comprehensive digital representation of the ocean. So let me just start about what digital twins are. You can think of them as virtual representation of the real ocean. So you have the real ocean on the one hand side and the virtual representation ocean on the other side. And it's informed by them. And there's a two-way interaction between the two for digital twins, that observations from the real ocean will refine the twin, make it better. But also we can manipulate the twin and do these what-if questions that I'll talk about more in a moment. So what these digital twins really allow you to do is to optimize your intervention strategy by asking and answering these what-if questions. From a benefit point of view, they empower ocean professionals, citizens, scientists, policymakers, and the general public alike to visualize, explore ocean knowledge, data, models, and forecast. So let me make this a bit more specific. So on the left-hand side, you see a very simply graph of what this digital ecosystem might look like. On the one hand, it is supported by, in part, but also supports international science around the ocean. But it's quite relevant for governments, and some governments are already engaging with this digital twin framework for their governing of their ocean space, let's say the exclusive economic zone or bays, harbors. I think it's quite relevant for civil society in that digital twins allow a great platform for engagement to build out ocean literacy. And it's important for the private sector, for many of the business that they're doing in that space. And they are early implementers and quite active there. But I think it also has opportunities for education. So the next thing what I would like to do is just share you my view on how digital twins, on the one hand, build on ocean information supporting services, but actually really informing interventions in the ocean. So I'm going to show you two slides which look at value change. This is a value chain from an ocean observing system for the Atlantic, but the global ocean observing system value chain looks similar. On the top, you see the benefit areas of ocean information, which can be around optimizing shipping, mariculture, fishing, tourism, and mitigation of hazards and the like. And these will require access to ocean information, which is provided by an ocean observing system, which is shown here, which then provides the data that come from in situ or space into data portals of some type. And they can be used to feed models and provide prediction to society. And then one hopes that these predictions enable better operations in the societal benefit areas. Obviously, there needs to be a feedback loop to show us whether the data that we're getting are adequate, or whether more data are needed, or the predictions are helpful. But the critical thing about ocean forecasting is you are answering a question that is called, what is the state of the ocean today? And how will it change tomorrow? So it builds on dynamics. In information system theory and on mass theory, it is called an initial value problem. You have the initial state, and then you use dynamics going into the future. In twinning, you have something similar. You have an observing system, you have models, you have visualization, but the big difference is that twinning depends on interventions. So what you're really trying to understand is, how will the outcome change if I intervene in the process? So you're not letting the ocean dynamics go by themselves, but you plan an intervention. And I'll show you in a second what these interventions might be. So in that sense, these are more like what-if scenarios. What will happen if I do this? What will happen if I do something else? And in mathematics, we call this a boundary value problem, because you're changing the boundary condition of your dynamically evolving ocean. And that's exactly what you want to do with ocean interventions. You want to change the ocean to do something that you like, or you want to stop doing something that you don't like. So I'm giving you a couple of prototypes. The first digital twin prototype I'm going to show you is a very familiar one. It's an Earth system, and that Earth system has an ocean too. But the typical question you might ask is, what would the global temperature of our planet look like depending on how much CO2 you emit into the atmosphere? And the way we do it, we have emission scenarios here on the left. There's 4 of them. And then you take these scenarios and ask the question, what would the Earth look like if I do a high emission or a low emission scenario? So these are the what if questions. You run them through an Earth system. Get an answer here as an example, the global average temperature. Very much what the Intergovernmental Panel for Climate Change depends upon, our Earth system prediction capabilities. But it's a boundary value problem, because you're changing the boundary condition by your CO2 emission. So it's not a typical forecast, like a weather forecast. You're changing, in this case, the CO2 concentration. Another prototype, which is maybe more closely to the ocean space, is one, what is the most cost-effective mitigation option, or option to mitigate the coastal impacts? So here you imagine you're in some part of real estate on the coastal domain, let's say a built-up structure, and you want to thinking about, how can I deal with sea level rise? And from the action or the intervention point of view, you have different options. You could say, I'm going to use nature-based solution. Let's say I'm going to increase my coral reef to grow. I'm going to build out, say, mangrove forest or things like that. But you can also build out barrier islands or dams or sandbars. So these are all intervention strategies from the nature point of view. But you can also do artificial strategies like building out dikes and dams or breakwater walls, something like that. And at the end of the day, what you would like to know in a twinning setup, which of all of these interventions that I could do are maybe the most cost-effective, most socially acceptable, and for a number of different reasons, most acceptable in the policy domain. So how would you go about that? You take a global forecast, let's say, of sea level rise, you put it through regional and maybe even local model lenses, and then you just play out different sea level rise scenarios in your very local setting. And then you have to be able to intervene by putting in these intervention strategies like dikes or coral reefs, mangroves, sandbars. It's a very exciting frame, and very much clear that that is exciting for regulators or city planners for coastal protection. The last prototype, just to show you that this is something we already do. What is the most sustainable way to capture wild fish? Many countries that some of us are in have fishery or stock assessment models or fishery prediction models. So they're looking at the fish stock and see how it evolves under certain fishing pressures or fishing licensing or allowable quotas. And what you're trying to optimize is maybe maximum sustainable yield or some maybe lower version of that with some safety net. But here you're using a model, in this case, a fish population model, to answer this what if question. What if I higher my fishing quota, lower my fishing quota, change the time of year or date of access? So very much digital twin types of things that we have in our community that support decision making. What's similar to all of these twins is, so what do you need to make this happen? First, you need an observing system that is capable of delivering the data that you want. And I think digital twin communities and the observing system can be a very happy marriage, because you can co-design the refinements, the requirements, the type of data, the partners together with the digital twins. I think they will be a heavy user of the data, but maybe also give you an idea of where you need more. And digital twins can actually also really be used to optimize the observing network, so you get those answers that you want. Second is there will now be a useful digital twin without some predictive capability. So here there are some programs like Ocean Predict or Coast Predict under the decade that are trying to advance the ocean prediction systems. So these will be critical, and there's a decade collaborative center that we can work with. And here the idea is to really advance and talk about which type of ocean models do we need. They can be dynamic, they can be AI or ML, so machine learning or artificial intelligence based, different types of models. Some combination of them will be needed for the twins. The third element is the data perspective from a digital ecosystem point of view. I think digital twins will work best if we can share our data in some sort of democratic fashion. So IODE, ODIS, the services around us are doing that to some degree. I think it's important to, on the one hand, as I said, provide easier access or democratize the world, but it's also about trust and interoperability and standards. So I'm sure we'll talk a lot about that, because that's at the core of what ocean best practices is also doing, but not just. And maybe last but not least, at some point you need to access the digital twin information. And so there can be a wide range of activities, and I'm sure we're going to hear one or two. I'm most excited about what I'm calling decision-making theater. At Geomar, where I work, we have this Arena 2. It's a 180-degree dome. It's like a small planetarium where you can go inside with the stakeholders and look out a digital version of the ocean and make decisions about your interventions. In this case at Geomar, our intervention is a sampling program, and the information is seafloor visibility here. And then we optimize our cruise plan as an example of a decision-making. But this can be done in many different ways. We'll have access to browser-based systems that you're all familiar with, Jupyter notebooks for those who are more advanced, let's say insurance companies, but also GIS-type systems. We hear an example of that, but also maybe 3D immersive environments where you can thrive through the ocean and dive through the ocean and see how the ocean would look like under different development scenarios. So I think it's quite exciting to really think about all the opportunities to interact with digital twins, and making them easy to use, I think, would be a desirable outcome. So for this workshop, I'm quoting Jay here. Jay, I know, Jay, you have a project to develop a compendium of best practices, standards, and ontologies for digital twins of the ocean under the EU project Iliad that actually Ute is co-managing or co-proposing here. So I think there's quite a bit of opportunity here for us to think about how we can do this and how best practices can really facilitate and enable digital twins to be successful. I think that'll be the gist of the discussion. So Jay, I just quoted you here. Up front, let me just say that digital twins of the ocean are quite popular. The G7 group has been supporting it, and the UK hosted G7 last year, have actually, under the sponsorship of the G7, facilitated a great workshop that we had in May in London. And I see Justin here, who was certainly one of those instigators that had helped us there to make this successful. And we're still working on making the presentations available. I think there were some nice recordings of really excellent talks. So that's one avenue. The next one will be next year, hosted by China. And we also in Ditto, this decade program, we're just spinning up a number of working groups, and I'm sure we're going to hear in our discussions a bit more about them. Some of them will be around observing system, data analytics, prediction, data lakes, interoperability, interactive layers, visualization. We have a workshop on architecture and frameworks, which is farther along. Maybe it's even a decade project of its own called Turtle that Ute and colleagues are leading. And then we're starting a workshop on education, training, capacity development, maybe also one on outreach and communication. So there's a wide frame of action under this program that we can do. And for those of you who want to learn more about Ditto, please join the community. There's a website link we can put also in the chat. And that brings me to the end. So I think it was like a 10 minutes short summary of what Ditto is, what we think about digital twins of the ocean. But the substance of this discussion is really how can the ocean best practice system and the opportunity it provides help with this digital twin agenda. And I think we'll hear a number of perspectives today and in 12 hours about that tomorrow. And so today we're going to start our discussion with two interventions. The first one is going to be by Martin Hoogweg from Esri on the geographic information system as a foundational building block of a digital twin of the ocean. Quite looking forward to that. And the next one will be from Luis. And as I said, he's with FUGRU and the Ocean Decade Office in UNESCO. And his title is Enabling Digital Twins Through a Trusted, Inclusive, and Interoperable Ocean Data Ecosystem. And once we're through that, I'm going to hand over to Pierluigi a bit to set us up for some interesting discussion and questions. And then you guys are welcome to chime in. And my suggestion is we'll go through the interventions as they stand and then have a lot of time for discussions all together. All right, colleagues, I'm going to stop sharing my screen and now hand over to Martin.
All right, thank you, Martin. That doesn't happen too often when I can say thank you, Martin. All right. Let me see. You should be seeing my opening slide here. Right.
Yes, I can see it.
All right. Well, thank you very much. Good morning for me. Good evening for some of you. So my name is Martin. I work at Esri as a senior principal consultant, focusing on what we call emerging technology markets, of which digital twins is one. We're not just looking at markets, but also looking at emerging technologies, both Esri emerging technologies, but also technologies that occur and pop up outside of Esri that maybe affect what we do, right? So that's kind of the context in which I work. I don't necessarily work just with ocean organizations, but I work with commercial organizations, cities, and other types of government organizations, for example, that everyone is talking and thinking about digital twins and how they can help do their work better. I may have a few slides that kind of repeat what Martin was talking about, not knowing exactly the audience and the context. So I'll just go through these. And as Martin was talking, I actually included a few things that I think might be interesting. Of course, digital twins, right, represent a virtual representation of the real world, including those objects, processes, relationships, and behaviors. But also the interaction. I think Martin mentioned this also. Right? It's not just a visualization of the real world. It actually allows you to interact with the real world. And traditionally, if I look at Esri presentations, most of these digital twins are on land, right? Whether they are in cities or the natural landscapes on land or even inside buildings. Think about campus management or facilities management. That climate control inside buildings is actually a pretty traditional field where automation and control are already present. Everyone here has a thermostat in their house, right? That controls the temperature. You can set it up, lower it, and it'll automatically control your heating or your cooling and keep it comfortable in your house. That's in a way a digital twin environment, right? Very small, very localized, but still. So the question really is then, what does it mean to build a digital twin of the oceans? How can we add this to all these other twins and other things that are, if you look at sort of the common discussion around digital twins, are very present. What can we do to include oceans in those kinds of discussions in industry? Well, one way to look at it is at a generic model, if you will, for a digital twin. This is something that I ran into a couple of years ago. I did not come up with this particular model, but essentially it lays down several building blocks of what would be included in a digital twin. And I'll start at the bottom. I think those arrows that you see there are most important, right? Sensing the real world, presenting that in an abstract digital form, and then allowing either a user on this digital environment to control, or allow the environment to control itself and actually actuate a change, a control, an action in the real world, right? That makes this really a bidirectional digital twin. Modeling and analytics, of course, right? Because if it's whether it's a self-driving car or whether it's a digital twin for a shipping industry, for example, this is work that we have been doing with the Port of Rotterdam and a few other organizations, looking at what happens to a shipping container when it moves from, let's say, Singapore to Rotterdam to Hamburg to the US and so on. Can we actually learn from the journey of a container? And based on that, can we adjust how the shipping industry works? For example, if you have 5 shipping terminals or container terminals in a port, does it really matter to which of these 5 terminals a ship delivers a container, right? Does it, because that actually is how it works today. But you could make it so that the container just arrives in a port, and then the port will figure out where this container needs to go, right? That's a kind of automation of the actual movement of cargo. And the same model of a digital twin can be applied to the exploration industry, for example, who create very, very detailed diagrams of their underwater infrastructure. Where are the boreholes? Where are the service infrastructure? Where are the pipelines? And how can we address issues in those pipelines? And these are issues that directly affect the ocean, of course. Right, so different kinds of sensors, different kinds of data. In this case, we work with some organizations that have very high resolution sonar and LiDAR type data of the underwater infrastructure. And those are very big data sets that we need to deal with. A digital twin of the ocean could follow a similar model, right? There's a lot of work already done on sensors in the ocean. Esri is doing work with ecological marine units and of course maps of the ocean, etc. But it's not just okay, visualize what is there. It's also affect change, right? And one of the things that we have been doing at Esri for several years is this process called geodesign. And this is a slide that I just added in as Martin was talking, because I think it's kind of interesting to think of a digital twin, not just, oh, we need a 3D visualization of an environment, but we also really need to think about how do you do these what if scenarios, right? So you start with your existing conditions. Do you know what is there at the moment, or what was there in the past and how it has evolved? What are your process models, right? Climate models, but also dispersion models for how things move through the ocean, right? The big garbage patch, if you will, that is sort of floating around, and where does it end up, and how do currents change as climate changes, or as the temperature of the ocean changes, and how do species move around in the ocean as conditions change. Those models need to be connected to the data and need to be connected to each other, right? Some of these models may need to interact with each other, and that needs to be figured out. And so that term, or that notion of interoperability, applies to not just data formats, but also to modeling, right? Can models actually talk to each other? Suitability models, right, define constraints and potential uses, or capacity meaning what is available, right? What opportunity is there for, let's say, a species to settle in some place, right? Or what, based on the favorable conditions for that species, or for In this case, an oil, if you see, right, a slide from my port background, does a port want to remain an oil port or focus on maybe grain or become an industrial port? Those are high level decisions and directions that an organization building a digital twin needs to make. Right? Those high level decisions really drive or are driven by global developments, and those need to be translated to the objectives of an individual project or an individual area of interest, and so on. Once you have all of those four sort of main things defined, you can now evaluate impacts. And those impacts will be different, right? Financial impacts or environmental impacts or ecological impacts. And those impacts then will need to be evaluated against each other and against those main objectives and design principles, the core principles, as I call them in the slide. How do you measure sort of financial versus ecological versus environmental versus other types of objectives, right? So multi-objective optimization is really what this is all about, right? You have to satisfy multiple objectives in some way. So again, an agreement on how do you evaluate different scenarios and different outcomes, and how do you then present this, right? And then that may result in policy decisions or actual physical actions that you're taking, and that is sort of the feedback loop back into the environment. Now, just the digital twin of the ocean, right? As I was thinking about this since last week, as I volunteered for this particular talk, right? Well, I know it's gonna be multi-dimensional, right? We all love 3D views of the world, whether it's a subsurface, whether it's a globe, as you see here, but it's not necessarily the only view of a digital twin, right? Think back to the thermostat. You don't see a chart. Maybe you have a fancy thermostat, but I just see a number and I see my target, and it's two numbers, right? So that's it. That's my view on the digital twin. Sometimes a 3D model, right, as you see on the right-hand side here, may be necessary, but for me to make a decision, I just need a few numbers, or I need a time series chart extracted out of this complex 3D data. Now, interoperability starts here, right? Storing 3D multidimensional data. There are standard structures for this. For example, the NetCDF climate profiles. Those are agreements that people make on how to organize data in a very flexible and open data format that you can use to store almost any type of data. Right? So those agreements need to be made on the data side. So that data actually becomes interoperable and usable, right, without too much extra work. Digital twins cover multiple time horizons, right? It will be, you need to understand existing current conditions or historic conditions, right? So very typical dashboards, as you see on the left there, might show you those existing conditions. What is where, and can I understand what is happening? There will be sometimes short-term simulations. What you see on this particular slide is a small animation of ebb and flow at the Port of Rotterdam, showing you salinity movement. And of course, salinity affects buoyancy. Buoyancy affects draft of vessels. Draft affects how much cargo they can get in and out of the port. And because you need to make sure that they don't run aground. And so these are serious models that the Port of Rotterdam looks at for guiding vessels into the port to maximize their operations or maximize the throughput of cargo through the port. So these kinds of very short-term models, these models run every 6 hours, they forecast 48 hours, and the port uses those models to make these short-term decisions, right? Think autonomous vehicles. They make split-second decisions on whether to brake or whether to continue at a certain speed, etc. But there are also long-term models, right? Particularly in the domain of geodesign and climate scenarios that I've done some work on. You'll see sort of forecasts for the next 60, 100 years being made and evaluate against those different models. And very often, especially in climate sciences, right, you'll have multiple models that potentially disagree at least a little bit with each other. So you look at evaluating those models as a unison, right? Whether you create ensembles of those models, or where you literally compare one model to another, and then based on that, you make a decision, right? So these are three very different time horizons. Think for historic and current conditions, big data stores with historic time series data and other types of data that needs to be accessible also as a historic archive. Right, that brings me to this next point, right? Digital twins, digital twin of the ocean, but others will produce and consume big data. Think about deep learning. The image on the left is detection of catfish I believe in Florida, sort of off the coast. The point is, these deep learning models, they take training data. Training data is large data by itself. They produce big data on their own. And once you've detected these catfish, okay, now what do you do with this? Right? Maybe in the end, it's just abstracted and you just get a density of catfish at this particular moment in time. And then later on, you do another analysis inferring sort of catfish locations or otherwise. Right? So even though at the analysis moment, you might have large amounts of data, at the decision moment, you actually might have aggregated, reduced amounts of data. Time series analysis is different from spatial analysis. And so we've been building some tools, but there are advanced tools to recognize trends in time series data that then can be used later on for analysis. This trend analysis is a thing that allows you to learn about how a system behaves, right? A natural system behaves. The map that you see there, again, from Rotterdam, I mean, made in Holland, right? So a little chauvinistic here. The Port of Rotterdam uses vessel locations that they are collected at every 5-minute interval over 20 years of time. And think about the number of ship movements in a port like this. Then they do analysis of, in this case, busy areas, right? Ship density. Where is the busy area in the port, or what time of day of the week, etc. Can we learn from this how this system, almost as an organism behaves, a living organism behaves? And then based on that, we can create these models that then do forecasting, prediction of those ship movements, or understand flows, goods flows in their case, over the future. If the number of vessels increases, it's going to put a strain on certain parts of the port. It's going to put a strain on traffic flow because some cargo goes over land. Maybe you can mitigate by using inland shipping as an alternative for road transport, or rail as an alternative for road transport, and mitigate some of these impacts. Those kinds of, let's say, thought processes would need to be identified for the oceans also. Okay, so how do you then make this data available? So I've done a lot of work on spatial data infrastructures in the past. Actually, I think Jay and I met many years ago when I was working on the Group on Earth Observation System of Systems, which really tried to connect all these different data catalogs, make data accessible and discoverable in interoperable ways. Right, so starting with a single clearinghouse or catalog, or multiple of those, each representing its own community of interest, right? Whether it's an ocean observing system, or whether it's a national government-based spatial data infrastructure system, all these individual catalogs exist out there. But it's hard. It's hard to find data because you have to know about the existence of these catalogs. So that kind of over the years has led to federated catalogs. I register my catalog in your catalog so that your users can discover my catalog and then go to my site to discover data that I might have. That connects these catalogs, but it still requires a lot of manual action of users to find data. And if I don't look in the right place, I may not find the data that I need, and therefore my work is kind of is limited in that sense. So what we have been promoting is more of a federated GIS. Yes, those data catalogs are connected, but the data in them is actually directly accessible and connected and usable in a federated manner, which means that as an organization that might provide data, I need to anticipate that it's not just my own users who use this data, but it might be users that I don't know about today that might use my data in the future, which then puts some, let's say, requirements on the infrastructure that I make available or that I use to make available this data, so that the services are actually ready and usable and available and reliable right? So these sort of more IT infrastructure requirements are going to apply in this federated environment. Data spaces, data meshes, data fabrics are all terminologies for very similar concepts of distributed catalogs where you have multiple systems that manage a portion of the data, and then this data is usable in a joint environment. If you think about Microsoft or let's say Amazon twin approaches, they take this approach, right? We have data coming from source systems, it gets ingested into a digital twin environment, sometimes a digital twin graph, and then the digital twin operates on this layer, on this integration layer. Well, how can you do this integration? Well, we identify, let's say, these 4 main patterns of integration. Not a complete exhaustive list, but these are things that we see in our work. Obviously, you can do data exchange, right? You can integrate traditionally at the database level or do what we call extract, transform, and load operations. Data, I take data from this one environment in one format, I ingest it into my own environment, maybe in a different format, maybe in a different data model, so that I can then use it in my system. This can work well, and this works very typical in let's say, an enterprise environment where you have asset management systems and customer resource management systems that connect to each other, exchange data, and so on. But if you think about my comments about big data and time series data, historic data, that is a challenge, right? In the big data world, you do not move data, right? You actually bring the compute resources to the data is typically what is being said, right? Because the data is too big to move. You don't want copies of your historic database. Well, that kind of brings me to some of these other integration patterns, right? Think about a web services-based approach, which is what we advocate for this federated GIS, right? A services-oriented architecture, nothing new, right? Has been around for many years, but also very much focused on very specific systems. And here we are talking much more about loosely connected federated systems where the services are not necessarily owned and operated by a single entity, but by many different organizations. Webhooks is a fairly new technology that allows you to build event-driven integration, right? So it's not necessarily a daily data extract like you see on the data exchange pattern, but it's much more event-driven. I need something happened, a ship entered a port, or an area, a fishing area, for example. Now we need to do something, right? So this webhook is a way to achieve that, and ArcGIS supports those kinds of webhooks. There are many different APIs, right? Esri makes our own ArcGIS APIs. We implement OGC APIs. Those are one way to make those APIs interoperable, but just an interoperable API, I'll go back to my comment about these federated GIS systems, doesn't mean the service is reliable, is actually available, and is permanent, right? It's organizations change infrastructure, a machine gets retired, a new machine gets instantiated with a new name. The old service URL will exist in metadata catalogs around the world. I can guarantee you that. It's not very hard to find examples of this. So these kinds of things mean that an interoperable system requires more than just an interoperable API. That's my point. So then there are application widgets and custom development. This is more, you might say we're moving up the stack, if you will, from the data to web services to applications that consume these kind of web services, integrate within systems. Widgets, right? That's what we typically call this. You can develop these in the web, or you can develop these in desktop tools, or connect, for example, ArcGIS and a system like R, right? For statistical analysis, where someone just wants to do a few spatial analyses in R. They can get access to those. They can get access to the data directly. They can feed data back to a GIS system through this, for example, a bridge, and establish integration. Big Data Toolkit is listed here as a technology to bring analysis to the big data, right? If you have a big data environment, you can do spatial analysis in that environment. And more, we see this analysis actually happening in what is called the edge, right? Fog computing is another term that you will hear about, where some of the computing happens really close to the actual physical environment itself. Think roads, think rail, think cities with traffic lights, right? Where smart systems local to the intersections will coordinate between themselves and regulate the traffic lights. And then, of course, end user applications, right? And here we see a full spectrum of traditional desktop GIS, like ArcGIS Pro, to web-based applications, as Martin had a few examples, to game engine integration. Actually, some of that Martin was showing also. Right, so how do you consume these web services, showing big data or doing analytics in these game engines? And game engines actually bring a very nice new, let's say, simulation environment by implementing some physics engines inside these game engines, right, directly. So it's a kind of a new environment for us to work in. Now, this requires interoperability at many different levels, right? And ArcGIS we see as an open geographic information system. Supporting open data, right? So users can make their data open. We do not control their data, so they control who gets to see their data. Users can interact with data from many different formats and so on. Development is supported with open source products and projects. I happen to manage an open source metadata catalog called GeoPortal Server. We have over 500 projects on GitHub and other code sharing platforms that allow you to build and use them. And some of these are these add-ins, right? These extensions to existing technologies, or libraries like Esri Leaflet that allows you to develop and consume Esri very prominent at the moment. And then there are standards from industry, whether they are the geospatial industry or the maritime or the hydrographic industry, or specific other industries around security. Think about a sensor network that controls your environment and your system. How do you secure this network? And there are some people who say that almost half of the investing in a digital twin will go into security type applications, right? Making sure that no one can spoof sensor data, making sure that the analysis cannot be let's say forged and faked and so on, right? So there's this a very critical part of this federated system, right? Do you trust the people that provide you the services? And API is a standard way of interacting with this content. Okay, so ArcGIS supports a digital twin of the ocean. I'll come to a close here. Right, so we provide observing systems and data spaces, systems of record, as we sometimes would call these, where organizations maintain bathymetry data, or the ecological marine units, or other foundational data sets. People make those available to the world, for example, through the Esri Living Atlas, but also through their own environments and their own data catalogs. We provide interactive and visualization technologies. Right? Interactive and provisioning is one of those building blocks of the ocean digital twin that were identified. Whether they are real-time or analytics based, and then include visualization either in sort of 3D web viewers or game engines or desktop environments and so on. We do a lot of work, of course, on analytics and prediction by integrating with external models, right? Climate models or ocean flow models, or other types of either short-term or long-term models, and allowing you to do these geodesign processes in environments. Simulation in game engines is sort of a newer area that we work in. And then, of course, outreach and collaboration and sharing through hubs, if you will, websites where you can go to discover data or discover and collaborate with others on building digital twins, or through learning. At the moment, there is a MOOC happening on data science that is available for people, right, to understand how you work with these things. Well, I think a digital twin of the ocean can benefit from some of these types of, let's say, learning lessons, right? So we'd be interested in work in supporting Jay and where we can with how we see best practices being taught to the to the community. So this is, I mean, maybe a few slides that I had on how I see digital twins and especially digital twins for the ocean. I'd be happy to discuss this during the discussion.
Yes, thank you very much, Martin, for this extensive overview of what Esri is doing in this space. I think it was a fascinating journey for many of us, so thanks a lot. Let's just move on without further ado to Louis. Louis, I think you asked in the chat, 10, 15 minutes would be fantastic, so then we still have some time for discussions left. Thanks. Louis, you are muted still. You need to do one more thing. You still have to work. I can ask you to unmute, but I can't unmute you. So.
Better?
That sounds fantastic.
Okay, thank you. Sorry about that. Suddenly the Zoom screen disappeared. I can't find it anywhere. All right, can you see my screen? You can. All right, brilliant. All right, so thanks very much. Good afternoon, everyone, and thank you for the opportunity to present. I am part of the Ocean Decade Coordination Unit embedded here in UNESCO in the Paris office, and I am seconded by a private company called Fugro, which is the reference that Martin reference to. So today I'm wearing my UNESCO hat, and I'll briefly talk about some of the initiatives within the UN Ocean Decade towards a trusted, inclusive, and interoperable ocean data ecosystem, and how that can support digital twins. So it's not really a technical presentation. It's really more about strategy developments and some concepts that hopefully can feed into the discussion that we'll have right after it. So off we go. We've heard about the Ocean Decade. I just want to point out that the Ocean Decade framework revolves around decade-endorsed actions, which typically fall into 4 categories: programs, projects, activities, and contributions. And really, it's in the programs and projects where ocean data is used, generated, information products are generated, and so on. And today we have 44 programs and more than 190 projects that have been endorsed. And underpinning all of that, of course, is the need for open, accessible, and interoperable data. So if we look a little bit, and this is going to overlap a little bit with what has been said before, but if we look at the value chain of these decade-endorsed programs and projects, from sensor to end user, we start to see a picture of what a digital ecosystem could look like with 4 key components. You have the observations that bring in the data. There's a data management and data sharing component. Then that data processing and into the models for the prediction to extract the insights that are then delivered to that end user and support that end user with decision making, policy development, and so on. Now, that end user delivery is often the very visible part of the whole chain, and that's why I kind of represented that iceberg analogy there, because it's all very nice, and often what we see is that a lot of the return on investment is placed on that actual end user delivery and that online web application, but actually none of that can happen without all this underlying infrastructure underneath it, as several of the co-presenters have mentioned today. And I just wanted to add in here, my vision of the digital twins is it's both that end user delivery, but it's also that entire value chain, if you will, with the observations, the data management, the modeling, and the actual web-based application, as Martin explained there. So one of the things that we're doing, because we see that repeated in a number of programs and projects within the Ocean Decade, we've set up the Ocean Decade is a very decentralized organization and management. And so what we've come up with is some entities that are called Decade Coordination Offices or Decade Collaborative Centers. And these are entities that are set up, for example, by Mercator or other branches of IOC and UN agencies, really to coordinate these decade actions, these programs and projects around these specific themes, so around observations. So Goose has set up a coordination office around observations to look at, and really to ensure that there's as little overlap as possible, so that we really channel the funding and the resources in the right direction, make optimum use of those. The same with data management and sharing. We've got one, IODE is currently setting up one for that. And then Mercator International has just finished setting up a collaborative center around ocean prediction. So that'll be a huge help in really coordinating those activities. Right, so the issue with all that is that the Ocean Decade will have many such digital ecosystems, each with its own requirements, deliverables, and there will be literally and figuratively a vast ocean of such digital icebergs, if you will. So we can either leave those to float independently, or we can find ways to pull them together into a collective based on common themes and best practices, and that's where those those collaborative centers and coordination offices can help. But also beyond the Ocean Decade, we realize that there are a number of difficulties that scientists and other ocean users are facing, and that kind of reflect this scattered landscape. So difficulties in finding, accessing, and using ocean data. Data are rarely interoperable, and that makes it very difficult for that data to be immediately usable in existing models. There's issues with understanding the quality and the provenance of some of the existing data. And then, of course, there are significant gaps, right, in ocean data, both in variable or data type, but also temporally and spatially. And then last but not least, there's limited connections across disciplines and sources, right? If we think about how we can access and use non-ocean data, socioeconomic data, or even local and indigenous knowledge, right? How do we integrate all of that? And by the way, these are not dissimilar issues that we also face within corporate organizations such as Fugro, right? You have individual teams that have their own processes, their own ways of collecting the data, their own ways of processing in that. And if we want to make use of all that incredibly rich data that we collect and work, we also need to find a way to build those ecosystems inside corporations themselves. So there was quick realization within the Ocean Decade that we need a strategy for data and information management. And so what UNESCO and the Ocean Decade coordination team came up with is to set up a group called the Data Coordination Group. This is a group of 25 scientists from around the world, and I'm happy to see Uta and Pierluigi on the call, who are both part of this group. And the key responsibility of this group is to come up with a data and information strategy, or actually a strategic plan, but let's start first with the strategy and then we'll figure out the implementation plan. And so we've been working on this for just over a year now, and come up with at least the broad lines of a strategy, which is a trusted, inclusive, and interconnected ocean data and information ecosystem that is actively used for decision making to address the decade challenges, right? So important to point out here that the Ocean Decade is not about science for science's sake. It's really there to develop solutions so that we can reverse the decline in health of the ocean and find solutions for sustainable management of its resources. I also point out another group that's currently being assembled, which is the Corporate Data Group. This is a group of private sector companies where we're going to sit down and figure out what are the obstacles for them today. They're not sharing their ocean data, their privately held ocean data. Why, what are the obstacles, and what are some of the solutions we can find? So those are some activities currently going on within the Ocean Decade. But it was clear from the start that we're not going to, no single data information and knowledge management infrastructure will be able to support the Ocean Decade. Instead, we're looking more at, as Martin was suggesting, more of a federated approach here. And I'll come back to that in a second. So how do we actually implement this strategy? Well, that's something we need to figure out in detail, but we did do a first step towards that. And that was just this weekend, the 4th call for decade actions was published, specifically focusing on Challenge 8, the digital representation of the ocean. So we took that opportunity to say, hey, here's our opportunity to provide some initial guidelines that people can follow to start working towards this idea of interoperability interconnectivity, open, fair, etc. So some of the things that we focused on in these guidelines are, well, let's ask people to come up with a data management plan, or at least for them to start thinking about it. We can't really evaluate their proposals on that yet, but let's have them start thinking about that, where they talk about things like metadata standards that they're going to use, where and how are they going to share the data, how about quality and provenance, how are they going to handle that, etc. And then there are other guidelines as well, all focusing on not just the data and the observations and data collection, but the whole value chain, right up to, you know, what decision-making processes are they supporting, what end users they're supporting, etc., etc. And of course, focusing or encouraging these actions not to try to find existing frameworks and infrastructure that they can leverage, rather than trying to build something completely new from scratch, right? And then last but not least, making sure that in that data management plan that they actually resource the time and effort that it takes to make sure that they can share that data and make sure it's interoperable, interconnected, and so on. So that's just one way that we started implementing that. Something else I wanted to mention, and this is something that Pierluigi is extremely familiar with and can probably explain it much more eloquently than me, but we want to go from this very scattered landscape with hubs and data repositories, databases, platforms everywhere, to something that is how do we go from that scattered landscape to something that is much more connected, right? Of this vision of an open, interconnected, and interoperable ecosystem. So all these guidelines that we're just talking about, you know, we recommend these metadata standards, etc., and we do have data policies and existing standards that we pointed to in those guidelines. But ultimately, we want all of this to help people save time, access to more data, right? These are some of we focus on the benefits, but at the end of the day, it needs to be something really simple that people can do, right? And I think this project that I just want to briefly mention, the Ocean Info Hub that IODE is running, and it's a pilot project over a number of years, will really help in that sense. So the idea is that it's kind of turning the tables around a little bit, in the sense that instead of if you have produced some data and you need to upload it, you've been told you need to share it, you need to upload it to this data repository, it actually would enable owners of an online website with data on it to actually publish that data themselves through the system. So the underlying architecture is ODIS, and essentially it's using some code that you can apply to your own website, to your own HTML pages, that will allow, through some indexing and some cataloging functions, to make at least your metadata visible, findable, discoverable, and then eventually, as you can also choose to make that data accessible as well through whatever level of accessibility you need. So it is really interesting, and I think some of the proof of concept has as far as I understand, worked quite well, and there's a number of regional, national databases that the project is working with to allow that to happen on a to scale that up, let's say. So always based on the FAIR principles, of course, and the Ocean Info Hub, and really also can provide a solution for things like indigenous and local knowledge, where they might be able to share the metadata but not share the data itself, but they make that decision themselves through this approach, right? So I think really interesting approach there. Let's see, what else did I want to say? Okay, well, let me just run through to the end. So like I said, not so much focusing on the technical aspects, more on the strategy development side of things. But what is the expected contribution of all this once we do have that digital ecosystem up, at least for the Ocean Decade? But of course, the ambition is that some of these best practices will percolate through to other programs and initiatives. Well, yeah, obviously a dynamic and inclusive ocean information system, open for all, right? That's at the end of the day what we need and what we want. and this will help build such a system, so that we can enhance that discovery and improve access to ocean data and information services products. It can provide global access independently of development stage or contribution. So that's an interesting point as well, related to that capacity development idea. But it also will help realize the full potential of digital twins, right? And help strengthen science, technology, and our understanding of the oceans. And I also think that it's mutual, in the sense that digital twins will also be a tremendous tool for figuring out where are those gaps still, where is that lower quality data that we need to improve. So it really is that mutual benefit, isn't it? And I think digital twins can play a huge role in that. But also, last but not least, really support this digital ecosystem together with digital twins, as has been said before, can support capacity development, address knowledge needs at national and regional requirements, and finally improve management and decision making for the sustainability of our ocean ecosystems. And I think I will leave it at that. Thank you.
Thank you very much, Louis, for that perspective. And I was really glad that you also in particular highlighted one of the important aspects of the decade being a UN decade, you know, with the motto, leaving nobody behind. That means, as we're discussing this, how can we make sure that the whole planet some way or form can benefit from that? So it's in particular looking at, you know, say countries from the global south, but also communities of the types that you mentioned. And I think that's an important element to always sort of keep in mind.
Yeah.
Louis, you can unshare your screen if you know what to do. Here's a button you push, and then I would like to invite Pierluigi for a few comments, and then we enter in the open discussion. Pierluigi, you want to take the floor?
Stop share. There we go.
There you go. Thanks, Louis. All right, so some brief thoughts. So again, we have a lot of action, we have a lot of activity happening, and we are trying to get these things to interoperate. But there's going to be a potential of a lot of confusion into who needs to manage what on interoperability, and what do twins have to do with it? How do they fit in? So we have to be really careful when we're talking about best practices, because everybody claims that they have them without actually proving it. And this is getting quite irksome and also destructive. So we have to get real about this. We have to actually test, and we have a global community through Ditto and other programs, and also all the twins we saw at the G7 summit that Martin mentioned. Esri's twins, we have NVIDIA developing their own, we have companies developing the Unreal Engine, creating wonderful visualizations, and we have to balance these things in a very realistic way, lest we mislead the community a little. So here's some reflections and challenges that I hope that people can respond to in the discussion, and be brutal. This is a workshop, let's do some work. Right, so the interoperability problem, Louis mentioned some of the work that we did on behalf of IOTE or IOC. It's the same for data of any kind. It's the same idea that things are usually internally interoperable, but they're under their own data governance regime, so they're not globally interoperable. And that's a little bit of that's actually a big issue. Twins are no different from this. It's just a more complex scenario to work on. So taking the same thinking, the same is useful. The way that the implementation plan for the decade laid it out, that this idea of having distributed but interoperable forms of data linked using this linked open data principle will work also for twins and their modules. So we don't have to reinvent that. It's just another digital asset to measure. There are many. When the cloud was there was a similar sort of buzz, but it comes down to basic logic at the end of it and good strategy. So we'll pick up from that that implementation plan. Let's pick up from that previous thinking. When we go into these very high-level fora and we're talking about the outcomes from these, they're valuable, of course, but let's not get a little starstruck by that, because there's some hardcore engineering that we need to do underneath it to make sure the thing works in the end. So when we're doing this, we also have to keep in mind, I mentioned some of the interests that are afoot. Amazon has its twin implementation environment. We have the Europeans creating a twin. Of course, the language there is we are creating the twin, but of course there are many. The US is catching up. They have the capability. They're just not captivated by the idea quite yet, but they will move quickly because of their private sector. So we have to prepare for many twins of the same real world entity popping up. And of course, with many twins, they are serving different needs, different requirements. They will show a different picture of the world because we're dealing with different value systems, different value chains operating at the same time and often conflicting. So we have to get real about that. And that's why the interoperability of the twins is so important. So we can say, well, I disagree with you there. Here's my visualization layer. See what your twin does when you plug that in. So that's quite important to have that sort of plug and play mentality for these modules, this careful modularization of these aspects. And that's when we start talking about really working together. You know, interoperability is nothing more than that. If you cannot demonstrate that the things work together, let's cool it with the interoperability narrative. So again, we went through this at the G7. I'm not going to spend a lot of time. Some of the previous speakers also mentioned the elements and components of the digital twins, all of which need their own interoperability regimes. Things like model repositories. There are lots of models out there, but they don't necessarily interoperate. I can't call and plug and play models and throw around parameters in a very easy fashion at all. I have to sit there and do something boring like read a paper to figure that out. I need to be able to, for my machines to call those things. Of course, the user interface, user experience layers are key to addressing different kinds of stakeholders. But again, those have to be custom developed in a certain project, which takes a lot of resourcing that many nations cannot afford. And being able to push and pull those is quite important. Same thing comes with the knowledge representation, semantics, ontologies. All of those need to be plugged in, and they themselves need to interoperate. Often they don't. Often if you choose one, you're stuck with one, and that's an issue. Some of us in the ontology world are trying to create that an automated interoperability layer between ontologies so the user doesn't have to decide. And that's a mentality I think we need there. It goes on to everything else, to the AI, etc. So all of those are modules, ingredients that we need to figure out, and perhaps through Turtleroot and others, where we can specify how people with these kinds of digital assets can share them effectively for twins, but also beyond twins, because the interoperability problem isn't twin bound, as we'll see shortly. So again, just to refresh, you have a thing in the world, you have a bunch of sensors sensing that periodically, you get an imperfect representation of that thing, you call upon an interoperable model store to patch gaps, not all of them, most of them, and then you call upon visualization models to try to make it look as pretty as possible, or as was said very, very well earlier on by Martin, maybe not to represent the thing exactly, but gives an informative dashboard or informative figure that can work. Anytime you put in sort of theoretical values to that, you can then do these what-if scenarios, right? You clone the twin, because it's no longer a twin of the real thing, but you clone it and you play around with it. But everything in those, including the theoretical aspects, the what-if scenarios, they also have their own interoperability concerns, and they have to extend and exist beyond the twin. We heard about the digital ecosystem. Some parts of that are going to be very twinnable when you have very dense areas, when we know that people are exchanging interoperable data about something, Port of Rotterdam, for example, then we're in a twinning scenario. And the more we can do that, the more we can actually make that integration on demand. So I don't have to figure out your API because your API is already pushing out your data in global standards or something that the community has agreed that they can understand. That social part of the engineering, then we're talking. Digital twins are just going to fall into this digital ecosystem. There'll be parts of them, and there'll be nodes or hypernodes, as we'll see a bit, in those systems. We have to decide that how they're going to communicate with each other, and also other nodes that are not as flashy. How do they communicate with the model stores, the data flows, etc. And of course, if we build a twin, it's going to rely on some far less flashy, as said at the G7 too, the plumbing underneath the sparkly fountains. They're going to rely on that. So how well resourced those systems are is going to be instrumental to the health and the sustainability of the twins. So Louis presented this very well. The observation layers pumping in data to the system. We're calling upon things coming from the modeling layers. Different applications will be harvesting that data through a primary, a first order interoperability layer, and then pushing back into that so that then they become part of that growing digital ecosystem. This is then the vision. Those DCOs and DCCs will be positioned here to help that along. And it's important that we're careful about that, where we're specifying this interoperability. One trap is that a digital twin inside a digital twin is another digital ecosystem that is specific to that twin. That's where it's going to do its ingest, its transformations, its model integration, etc. It's important not to get that secondary or second order interoperability layer confused with the first one, because they have to interact so that there's a commons that is globally available while people are busy doing a very challenging job of building a twin. Getting that communication is important for developing recommendations, standard operating procedures, suggesting what could be a best practice. We have to make sure that we're talking at the right level. Right, so let's be careful here, because we have a twin rush, just like a gold rush, just like the cloud rush. And there will be lots of iterations and quite a lot of noise. I think it's on us to discover the signal in that noise, and we have to make sure that we're not locking people in from one twin to another. If we do that, we're failing our mission. And I think many in the private sector are very well aware of this because they're going to rely on a lot of public data and also data from other private entities to harvest twins. Government twins will function in the same way. Interoperability is testable. And I think this is one of the challenges that I'm going to put out there to all of those of us building twins or twin systems. You cannot claim interoperability without proving it. If you're not working together with a third party, an independent third party that does not use your standards, if you haven't negotiated how to do that, let's again cool it with the interoperability idea. There's a difference between a kind of digital colonial dynamic and an actual interoperable and democratic dynamic. These sort of terms like digital sovereignty, digital colonialism, they sound kind of, let's say, a little bit high-level theoretical, but they're real. There are now national, international debates about the future of the internet and how digital sovereignty is going to play into that. Nations are preparing regulatory material. Europe is very active in this, so we have to be quite careful about where we're going to go. All right, so it's going to get complicated. There are a few challenges out there to start this discussion. So let's fight and see what we can do to make things a little bit better. Okay. Some suggestions, but let's over to you, Martin.
Yeah. Fantastic, Pierluigi. Maybe you can leave that slide up. And I really appreciate it, again, your perspective on this, because as you correctly said, there's some high-level objectives, I think, that we all share on, but it's actually the underlying architecture and that will either make this more easy for all of us or possibly complicated with risks of lock-ins and the like. Pierre, if I may have a direct question to you, and then please, colleagues, raise your hand if you want to engage in the discussion. And that is, if we want to establish some of the kind of ideas or concept that you're bringing forward, do we also need some sort of authority, shall we say, who is somebody who is actually capable of or able or has the trust or the mandate, whatever you want to call that, to set standards or to propagate standards, or whose job is that? I'm sure it's not my job. I mean, I'm sure, but maybe it's Lewis's job. I don't know. But what is community practice? What is standard practice? I mean, who should be part of our team thinking here? Who could take these things forward and establish standards in our space?
Mm-hmm. Louis, is it your job? I don't know. Probably not. But I think what I would point back to is what happened to us with the Ocean Info Hub and Otis project that Louis highlighted, right? So in the IODE context, it's a UN entity, it's neutral, it doesn't have a national or regional priority. Its objectives are not set by regional or national funders. And so what we did there is, rather than setting standards, we're sort of saying, all right, can we use the convening power of the UN to then set conventions, right? To say, all right, tell us what your standards are. But the key to interoperability is using those standards in similar ways and being able to crosswalk between them. So we create the forum for that to happen. And this is where the programs come in, I think. This is where Ditto and others come in, to say, all right, all of us developing digital twins or the underlying interoperability frameworks, let's use the convening power of Ditto as an action, pull in the stakeholders, and then try to figure out some kind of common norm which we can all project into, that everyone is mutually happy with and unhappy with. I see Martin has some feedback there.
Yeah, finish first. Yeah.
Yeah, fantastic. Thanks, Pierluigi. And now I see the first hand, Martin. Over to you.
Sure. I'll take. I'll give two perspectives. So in my work in spatial data infrastructures, I've been sort of exposed, if you will, to Inspire, which is the European spatial data infrastructure and its framework. Very specific data models, web service APIs, metadata standards, etc., which appears great, right? It's clear what everyone needs to implement, but everyone needed to change as a result of those particular specifications, right? The data model for cadastral data did not fit with the cadastral systems in use in all the countries, right? And the same with transportation, the same with health, etc. So it's great that there is a community of standards and a series of standards, including things like standards compliance testing, right? Test suites, etc. But it did not actually solve the actual problem of being able to create integrated pan-European data sets or views of let's say, the environment in Europe. So just standards alone is not sufficient. And there are a lot of sort of mechanisms to create these standards already, etc. So that's one perspective. And a slightly different approach is what I'm seeing in working with the petroleum industry, where a lot of the large mining and exploration companies are actually working together in what is called the Open Subsurface Data Universe, which is an initiative led by, or facilitated by, I should say, the Open Group, and where all these basically competitors, private companies that compete in this industry, work together and actually implement specific technologies to really prove the interoperability, prove the integration between systems and platforms and so on. Different model, takes a lot of work, takes a lot of commitment from these organizations, but it's going to result in systems that actually have been shown to work together. Whether they implement some international standard for data exchange or integration, or whether they implement, let's say, a community standard for integration, right? So those were two very different models that I think are interesting to take a look at. If you're looking for how can we do this and what do we need to do, I would look at different communities that have taken a different approach.
Yeah, thanks for that perspective, Martin. And but the one, just reacting a little bit to that is, I mean, I'm fairly familiar with the ocean community. I'm less familiar, but somewhat familiar with also the atmospheric community. And I will say, when you look at, for example, interoperability now, in this case, that is outputs of models of some types. In the meteorological community, that's fairly well done. It's because you do have the power of the World Meteorological Organization, which has been around and really facilitated some of these, let's say, good and best practices in a more normative way, just because the countries who signed up for that took it very seriously and were willing to sort of go along with some of that. Now, in the ocean space, that's much diverse. I mean, we also have sets of ocean prediction models, just to name one citizen in our team here. They have not agreed on the common output standards and variable names and so on. And that makes it very hard for a harvester to, let's say, ingest 4 or 5 or 6 ocean forecast models and give you, say, the upshot of whatever it might be. So I'm just feel somehow in the ocean community, although in theory, I would say we also have a UN organization, the Intergovernmental Oceanographic Commission, which could play that role, but I think de facto it isn't playing at that same level, although IODE is a good example because it's sort of under that. But I just wonder whether by using some of these bodies, but doing it in the way, Pierluigi, I like the way you phrase it, let's not push it through just because there's a standard, but if a community standard emerge of some type that is attractive, could we also use our UN friends and organizations to actually put some legal stuff around it? Because some of the governments would welcome that, I assume. I mean, here's a non-expert talking, but it's something that I'm seeing. So I wondered whether folks had a perspective on that, and I see Lewis does. So Lewis, over to you.
Yeah, thanks. So also a non-expert point of view, but and also a bit of a mix of both my Fugro hat and my UNESCO hat on here. You know, just like we quickly realized it was impossible to try to come up with a system that would have all the ocean data, and we said no, you know, we need to go more through a federated approach. And in a similar vein, I don't see one particular organization having the authority and saying thou shalt use this standard or thou shalt use this format and so on. I think I like the idea Luigi was talking about, more about conventions, and I also see maybe more emphasis on using technology and, for example, open source APIs that could help a lot of this rather than have somebody come in and fill in a metadata in a specific standard, have software and code do that for you, and that would be open source. So I see that more. I see more going into that direction, but then have somebody like the IOC with the responsibility of gathering the community on a regular basis, looking at these conventions and building, with the idea of co-design, really, of working with the community to come up with these conventions and the way forward, rather than trying to impose a specific standard. So that's kind of my perspective on the issue there.
Yeah, sounds very attractive, Lewis. Thanks for that. And Pierluigi made some good comments in the chat as well. Now, my co-chair, Ute, is here on the stage. So Ute, looking forward to hear from you.
Yes, thank you. What I wanted to say is this thing with the interoperability. I always look at it also as the democratization of things. So, like Pierluigi said, like if I'm not in agreement with somebody who produced a visualization of data, and then I can produce another visualization which I think is better or makes it more clear. So that gives also the opportunity for smaller players to be in the game, because if we really make it so interoperable so that we have these small building blocks that you can put together, and then you can make your own digital twin representation or your own solution. So that gives a lot of people who were not able to be part of this game of being a player in the ocean community because of the costs and the things that are so expensive, and having the backbone for computational infrastructure and so forth, they can suddenly also be in the game. And I think it was George who put it in the chat. So there are all these young gaming enthusiasts who are suddenly able to make great visualizations of these things. But the other thing I wanted to address is when you look into data science or you look into decision makings, then solutions should be very specific, and they are very targeted to solve a specific problem or very targeted to answer a specific question. So the challenge is, to which layer do we have to be as interoperable as possible, and from which layer, or if we want to call it a layer, from which part of this digital twin can we be very specific and still kind of be part of this interoperability framework that we are addressing here. And we are trying to do this in Ditto with this work group, and we are trying to do this in Turtle by saying, yes, we want to look and communicate with all the people who are currently developing these interoperability architectures. But I think this is really a challenge that we haven't solved so far, and that we have to continue working with.
Thanks. So we have a few minutes left. So before I'm going to give to Pierluigi for some final summary and summarizing his thoughts, maybe Magali, you wrote a nice comment in the chat. Are you willing to take the floor and just say it verbally, what you wrote in the chat, and then I want to invite Pierluigi to respond. Magali, are you capable, or maybe you're not?
Yeah, I'm trying to unmute myself. I think I got it now.
Yes, you did.
Hi, good evening. Well, I was piggybacking off from someone that was also saying that maybe maybe standards are not so handy for everyone, and that maybe we could have a format of for exchanging data. And I was thinking, yeah, maybe having if we study the backbone of everybody's structure, and we can find a way that we can find like the skeleton of what we have in common, and then we could have this translation between different tools, let's say. Not sure if I'm making any sense.
No, you do, Magali. Thanks. That I think was a helpful comment. So, Pierre, I'm going to give you the floor for the last 2 or 3 minutes before we have to come a close for the first part of the session. Again, tomorrow in 12 hours, we'll have a second part of that. Pierre, over to you. Pierluigi.
Thanks. That hand wasn't for that, but I can try. So to synthesize it all, I mean, I think we see similar patterns. We see that there's lots of complexity. There are lots of different technical implementations and architectures, which we don't want to interfere with destructively, because that's what local groups are using to build a digital twin, which is a complicated enough endeavor. Our task, I think, through Turtle, through Ditto, through IODE, through IOC, is to help make that something that can be sustained and also isn't leaving people behind. I think those are our 2 missions, right? So the digital equity is key. Even if you just can set up a website or a web page, some of your insight might be essential to building a digital twin. And it should be as visible as the major European infrastructures, the US infrastructures, right? And then that's what we need to find how to identify. So when we have our Federation of Twins scanning the digital commons, looking for bits and pieces they can stick together to make a good representation or a new what if scenario, they should be able to find that. And so I think this is the interoperability aspect. I agree very much with Magali. In that regard, like identifying what these core elements are is the first step. And then I think we can do this in a sort of progressive manner. First, really coarse building blocks and then getting finer and finer. And that's also how the humans will work to say, are you a visualization expert? Great, let's convene some groups thinking about this and then subdivide that problem down as much as possible into the various aspects of visualization. And then that's how we build our community. That was said very much earlier too, that sort of socio-technical system, building a community, but also organizing that community so that the conversations are productive and we move past show and tells and into really engineering, I think will be the metric for our success. Back to you, Martin.
Great, Pierluigi, thank you very much. So we have come to the 90 minutes, but before we close, and again, we'll continue the debate in 12 hours. Those of you who wish to open up your video so we can take a group picture would be appreciated. If you want to stick behind your icon, that's fine as well. I'm going to try to make it happen here. So who is willing to turn the camera on? Oh, I see a few more. Cora, I see. Fantastic. Oh, so many wonderful, engaged and enthusiastic faces here, very much. So I'm going to one more. 3, 2, 1, smile. Maybe I managed to do it. So I'll try one more just to be on the safe side of it. Okay, one more time, colleagues. Give us a smile and thank you very much for all the speakers. I think it was a good discussion, I think, for us to start. I think we'll have more to say on this space and we have more interventions tomorrow. Ute, you want to give us like a 1-minute advertising for what's going to happen tomorrow?
We can do. It's very early in the morning, but I can tease you that we will have great speakers, which I do not know from my heart right now. Joanna, please help me here. I can also need all the support to get myself into the session tomorrow, but I hope it will be as great as it was today. I took some screenshots and I hope I'm allowed to use some screenshots of your presentations, just giving a summary for the people who weren't here today. There were also questions in the chat that if we could share the presentations from today. They are supposed to be in a folder or something. That would be great. Joanna can probably help us with that, or Pauline. Thanks for your help so far. We will have 4 speakers tomorrow. As I said, one will be Justin Book, who is from the UK and speaking about interoperability frameworks that they implemented there. Another is Jeroen Broekhuizen from TNO, and he is involved in the biodiversity digital twin project, and they have started this year, so he will give us a glimpse on how far they have come. Another one is
Marjolaine Kroop.
Thank you, from South Africa, who will give us a talk, which I'm not sure what this is, what it is about, but I'm very much looking forward to that as well. And the 4th one is Dick Sharp from Blue Cloud, who will give us a glimpse what Blue Cloud is doing in moving towards digital twins interoperability. And then Pierluigi promised me he will be 80% available for tomorrow, so we will have the same great discussions or even more time for that tomorrow as well. So please join in if you want. Otherwise, we'll see you somehow, somewhere online.
Yes, in my final sentences, I think Ute and I would actually really like to thank Joanna Collard, who is here with us. She's been ably supporting us. And if you get some requests from Joanna, by sending the slides, and she's doing the recording, she'll put all that online. So those of you who are speakers, thanks a lot, Joanna, for supporting us here. Thanks a lot, Jay, and the whole Ocean Best team, Pauline and others, for allowing us to use your platform to facilitate this discussion. It's very much appreciated, and we're looking forward to see you all soon. Thank you very much.
Yes, and if we have forgotten anyone, we will come back to you.
Bye, everyone.
Bye-bye now.
Bye-bye.